This presentation is for the International Conference on Computational Science and Computational Intelligence. The title of the presentation is Web System for Visualizing and Executing Methods on Web Objects in XML. The authors of this work are Betzabet García-Mendoza, José Martí Hernández-Salinas, and Carlos Roberto Jaimez-González. We are from the Information Technology Department of the Metropolitana Autónoma University in Mexico City. This presentation is divided in the following sections. First, I will give you a brief introduction of the work that we are presenting today. I will also talk about some existing systems similar to the system developed. Then I will present Web Objects in XML, WOX, which is a framework for distributed objects and web services. After that, I will talk about the analysis and design stages to create the web system presented today. I will also present the web system in operation, and finally, I will provide you some conclusions and future work. Web Objects in XML, WOX, is a framework for creating object-based distributed applications. It supports the interoperability among different object-oriented programming languages. It uses XML as the format representation for objects, and it uses HTTP as its transport protocol. A web system was developed to complement the functionality of WOX, which allows the storage of distributed objects and the visualization of their state and methods. The web system has a repository and allows to display and execute methods on objects created with the WOX framework, where the user can provide values for each of the method parameters through a web interface. There are some systems that are similar to the web system that we are presenting: Corba Web, SubView, Pesto, Corba Object Browser, and Apache Axis. Corba Web is a system that acts as a gateway between the web and the Common Object Request Broker architecture, Corba. This system is known as a generic object browser. Its idea is to allow clients to view and invoke methods on any local or remote Corba object through a web browser. SubView is a system to explore a database in order to locate a specific object, retrieve its information, and view it graphically. In addition, this tool visualizes the objects in a hierarchical way and allows navigation in large databases by changing the base object, which is an object that becomes the main node through which the navigation begins. Pesto offers its own interface in which it is possible to navigate over objects. It is designed to explore object databases and offers the possibility of making complex queries of objects in databases through a language similar to SQL. Corba Object Browser allows accessing Corba objects directly from a web browser using a URL. It allows browsing and invoking Corba objects in the same way that users browse the internet. In this tool, it's possible to view and execute the methods of a specific object from a web browser. However, the user has to use a browser called Hot Java Web Browser, which is no longer available. Finally, Apache Axis is a web services engine, which is interoperable, implemented in C++ and Java. And like WOX, Apache Axis is an open source XML-based framework that uses SOAP for message exchange. Although Apache Axis works with objects, it doesn't save the state of the objects, so its methods are only invoked as if they were static methods. This table shows a comparison of the systems analyzed: Corba Web, SubView, Pesto, Corba Object Browser, and Apache Axis. A tick indicates that the system has the feature, while a cross indicates that the system doesn't have it. The features considered for the comparison in this part of the table are the following. The first one is open source, which refers to software that it is made freely available and may be redistributed and modified. The second is interoperability, which means that the system is capable of communicating on different platforms or programming languages. The third feature is based on objects, which indicates that the system supports the use of remote objects. The feature web services means that the system supports web services. The feature use of XML, which is the last one of this table, indicates that the system uses XML as a means of communication between the client and the server. This is the second part of the comparison table, which shows other features considered. The first one is visualization of objects, which indicates that the system allows the visualization of objects graphically. The second is visualization of attributes, which means that the system allows the visualization of the attributes that each object contains. The next feature is execution of methods, which refers to the fact that the execution of methods belonging to an object is allowed through a web browser. The next feature is web interface, which indicates that the system provides a web interface in which the user can view the methods of the remote objects. And finally, the feature database management, which refers that the system is able to navigate through object databases or repositories. Web objects in XML. WOX is a framework that combines features of distributed object-based systems and distributed web-based systems. WOX uses URLs to uniquely identify remote objects, following the principles of the representational state transfer, REST, architecture. This is an important feature because all objects are uniquely identified by their URL and can be accessed from anywhere on the web, either through a web browser or programmatically. WOX uses an efficient serializer called the WOX serializer, which is the basis of the framework for serializing objects, requests, and responses exchanged between clients and servers. This serializer is an independent XML library, which is capable of serializing Java, C#, PHP, and Python objects to XML, and vice versa. WOX has a set of standard and special operations that are applied on local and remote objects. These operations include requesting remote references, invoking static methods, invoking instance methods, destroying objects, requesting copies, duplicating objects, updating and uploading objects, and invoking asynchronous methods, among others. The functionality of the web system developed can be divided in a series of actions that can be carried out. Here we show some of them. The first one, access to a specific WOX object over the network. The web system allows its users to access a WOX object stored in the system from a unique URL generated by the same system. With this URL, users can directly access the object without having to enter the repository and search for their desired object among all the 6 existing objects in the same repository. The second is visualization of objects graphically. Here, users can visualize through an interface the attributes of a given WOX object. The third one is visualization of methods of any WOX object. Users can view all the methods that belong to a particular object, regardless of the parameters that each method requires to be invoked. Each method has a space to display the response that it returns when it is invoked. The fourth action is execution of any method belonging to the class of a works object. Through the web system, it's possible to invoke any method of a works object. There is also parameter verification to prevent the user from entering erroneous parameter values. This way, it is ensured a correct invocation of a specific method. And finally, storage of works objects on the server. Users are able to upload works objects to the server for later manipulation, either as a parameter for the invocation of an object or simply to store it in their repository. Now, there are some interface prototypes that were developed. This slide shows the interface prototype for the list of objects stored in the server repository, in which the following fields are displayed. As we can see in this figure, object URL, name, reference, and actions, which provides two options to the user. The first option is to view the object's attributes graphically, and the second option is to directly view and access the methods that the object contains. Now, this slide presents the interface prototype for a method invocation. It shows the object ID, the class name of the object, the name of the method to be invoked on that object, the parameters of that specific method with input boxes to enter the values, a button to execute the method, and an area to show the results of the method invocation. Now, I will show you the web system in operation. Specifically, I will show you how to visualize the methods of a specific works object and how to invoke methods on works objects through a web interface. This figure shows the operation of the system for visualizing all the methods of a works object. The operation is shown through a series of steps. In step 1, the user accesses the repository of objects, where every object is displayed with its URL, name, reference, and actions. These actions are view object and view methods. In step 2, the user selects the view methods link from the actions for a specific object. Now, in step 3, the system receives a request which contains the ID of an object to be manipulated. It proceeds to search for it in the object repository. In step 4, if the object is found, the system obtains the class of the object, and from the class, the system recovers all the methods and parameters necessary to invoke each method. In order to do this, the object uses Java reflection technology. Now, in step 5, a table is created for each method. Once all the methods and parameters of a specific class have been obtained, which will contain the following attributes: the method name, type of response that it returns when the method is invoked, button to invoke the method, text field in which the response will be displayed. In step 6, the system adds a form once the table that represents each method has been generated. In this form, the user can provide the parameters required to invoke the method. And finally, in step 7, once all the method tables belonging to the class of an object have been created with the respective forms to be invoked, they are returned to the user. Now, this figure shows the operation of the system for invoking a method on a particular works object. The operation is shown through a series of steps. In the first step, the user receives the tables that represent the invocation of methods on a particular object. As we can see in step 2, the user proceeds to fill out the form to be able to invoke a certain method. This is for the parameters. In step 3, during the filling out of the form, with the help of JavaScript, it is verified that the parameters entered by the user are correct. For example, if an integer value or type number is required in the form for the method, it will be verified that the user really enters an integer and not a decimal or text, for example. In step 4, after the user has entered the correct parameters to invoke a certain method, they can proceed to press the test method button. And with the help of a synchronous JavaScript call, AJAX, the response is displayed just below the table that represents the method to be executed. Without having to access another tab or refresh the browser page, AJAX sends a request to the server and sends all the parameters entered by the user for the invocation of a certain method. In step 5, the system receives the AJAX request with the following information: ID of the object that contains the method to be invoked, name of the method to be invoked, list of parameters required to invoke the method, and a list of classes to which each parameter belongs. Step 6, once the information is obtained, the system locates the object according to the ID provided. It is deserialized and the list of parameters is verified. The system, as we said, verifies that each parameter matches the class. In step 7, the system executes the requested method. Once the list of parameters has been created and verified, in order to proceed with the method invocation, a new object called answer is created, which will store the result of the method invocation. Step 8, the system proceeds to verify the answer, well, in this case, the answer object, once the requested method has been invoked, for which it obtains its class. If the answer is a primitive object, the result can be displayed on the screen as text. On the other hand, if the answer is a non-primitive object, then it is serialized with the walk serializer. Finally, in step 9, the user is shown a link to view the object that will be the response of the invocation of the requested method. Now I will show you some screenshots of the system in operation. This screenshot shows the visualization of the addBook method on the library class. In order to visualize the methods of an object, it's necessary that the object class is hosted on a web server. If this is the case, by pressing the View Methods button, the server will show the user all the methods of the object, with their corresponding fields to be invoked, as it is shown in this screenshot. This screenshot shows now the addBook method, which will add the book to a library object with the following parameters: book ID, name, author, editorial, and status. The bottom panel, shown in this figure, illustrates the results of the method invocation. The book has been added to the library object with the values specified. The results panel shows that the data type for the first parameter is int, and the data types for the rest of the parameters are string. There is also a message indicating that the book has been added correctly. Now this screenshot shows the addBook method, which will add another book to the library object. The bottom panel shown also illustrates the results of the method invocation. The book has also been added to the library object with the values specified. After adding 2 books to the library object through its methods, it can be displayed, as shown in this screenshot. It can be observed that the object has changed. It now contains the 2 books that were added previously in the previous 2 screenshots. Well, this presentation showed a web system that allows users to visualize and execute methods on distributed objects. The invocation of methods is carried out through a web interface where the values of each of the parameters are provided. The web system developed is a complement of the web objects in XML framework. WOX is a framework for programming distributed object-based application. The web system met the objectives set at the beginning of its development, since it was possible to successfully design and implement the visualization and invocation of methods on objects through a web browser. It should be noted that it is also possible to store objects in a repository where they can be visualized both graphically and in the XML representation. Further work is necessary to create an evaluation instrument to test this system with students of courses such as system integration, interoperability, and object-oriented programming. Thank you very much for your attention.